ನಿಮಗೆ ಕಳಿಸ್ತೀನಿ ಒಂದು ನಿಮಿಷ ಶ್ವೇತ ತರೋಗಿ.
Is it okay? At least if one of you raise your hand, are you able to hear? Raise your hand in the sense you have to show the sign there. For example, I will share the screen. This is the YouTube. It is running parallel. Yeah, this is with the sharing. It is there. Okay, no issue. Okay, in this class we will discuss the plotting of graphs, particularly the scatter plot, or linear graphs, or bar charts and pie charts. Along with that, how one can go for the linear fit method or the best fit method for some of the graphs. You can use the two modes. One may be in Excel, Microsoft Excel, of various versions, maybe up to 2016 or 21 or 2010, whichever you have. More or less, the method is similar. Maybe updated versions or maybe updated packages having more features. There is a great extent. At the same time, we can also use the plotting, particularly in Linux, where it is having a kind of an analysis purpose actually. Particularly, they will call it as a spreadsheets. Spreadsheets in Linux, they will use both are similar to that. Let us try to see that how one can go. You may be in the YouTube, no issue. Being this, are you able to see the screen once at least? One of you?
Yes, sir.
Okay, no problem. Here we have to get the data. Data can be obtained in such a way that first you save it on some of the name. Okay, either you press Control S or maybe let it be on desktop with somewhere with the desktop. So much of noise is coming there from your end. Like test one. Yeah, you can reduce your volume if you wish. All of you are in the same classroom, no? That is the issue. This is a test one. How one can go with the data? Simple data will do it. Let it be 1. Let it be, instead of that, we'll say that number. Okay? Number. Let it be 1, 2, 3. Maybe serial number. You prolong it for about some 10 variables. So maybe 15. Okay. And instead of filling the data, you can choose random data also. Or I will use some kind of a tool, 4, 6. Okay. Let it be 2 of that kind. Here, what you do, plus random between 1, 100. Let us choose. But the thing is that this copy, it will change every time. Paste these values as the value. Doesn't matter. Let it be 4 column of this kind. While plotting, either you can go to the plot in such a way how it has to fit. Let us choose these two, select the data. Okay. Assume that this is some kind of a number. This is some sample data. Always it changes. It is also some variable sample 2, for example. Sample 2. Okay. Sample 1 changes every time. Okay. Let it be. I will plot only the first two first. Then we will see that. Select. Okay, this one. Let it be 2 here. While going insert, go to the plot tools, any of them, whatever you want at least. Here recommended charts it will show. In the recommended charts, let it be a bar graph, let it be a horizontal graph. This is a line graph scattered with discrete line, only line graph, maybe pie chart, maybe bar diagram with the data they can call. Okay. Or you can go with the all kind of a charts. For example, I will choose one scattered curve, scattered X and Y, how it has to look. See that this is how y-axis changes with reference to the x. Y is your number, some kind of a number, or you put it as it is a number of apples fallen from the apple tree. Okay, with reference to the time. For example, if this is the case, it is the best. It is showing almost more or less same thing. Means whenever there is a dependency of y on x, y of x, then only have to plot this type of the things. Means for a first number, the 2 is the value. For second number, 4 is the value. For third number, 6 is the value. Or assume that it may be a distance. At first position, the number 2 is there. At second position, 4 is there. At third position, 6 is there. Why I am saying? Because the y-axis, the values which were written on B are depending on the values on y, x. On x actually. If they are not dependent, scatter plot is not a good term. Here what you are getting, for corresponding one, this is the value. For corresponding 2, this is the y value. For a corresponding 3, this is the y value. For a corresponding 14, this is the value. I can't interchange. For example, I am saying that. Assume that if you make this data in an increasing or decreasing order, I will put it as a sort, expand, no, continue with the current selection. Okay, how it should be there? This is the same case. Continue this. See that just I interchanged for first value number 30, for second value 2080. Immediately the graph also changed its properties. Means it is a live chart. It is a live chart. You can plot any of the data like this. Here, while plotting also, what it says that the values are decreasing as the x value increases. As the horizontal axis increases, the values of y are decreasing. I can say that some dependency. You click on this chart title. Okay, then you can enter the name. For example, number of okay, apples falling from the tree. Okay, from a tree. Here you can say that the x-axis here you can change this one actually. Either you can put the line, or you can put the dot, or you can put the solid line, or you can put the gradient line, or uh, or you can have any of those things, But while giving the captions here, see that you can click on this, it will show you that what kind of an axis one can put in. Class 11. What kind of the axis one can put at least. Means to say here where you can go. Format axis. Okay, minimum maximum values. If you want, you can change. Major axis for every 2 it is there. You can make every axis as let it be 1, for example, and figure caption should be there. 6 should be none. Then labeling should be there. Here no. I want to next to the axis. That should be. Okay. Add. Fine. Okay. If you add these things, Okay. Here access will come. Access will come in 2021. You can have the direct thing actually. You can vary it. If you want to change the, for example, symbols here, you can change the symbols whichever you want. Either maybe solid or of that kind. Maybe gradient also you can put, or automatically it can take whatever the symbol. If you connect this line, okay, it is showing the order in the sense for the first value this is a one, for second value this is a one. Assume that if second value is missing, remember here, okay, I will change this, I will delete this 28. What you will get? There is no connectivity. Why connectivity has lost? Instead of 28, assume that I will delete somewhere here 18. Connectivity is lost. Can we connect these two lines or not? We don't know. If we know what will happen in between, then only we can connect. For example, some phenomena is happening in such a way that it decreases from first till the value of the sixth. Seventh value is missing. It may come down or it may reach here. It may increase or may decrease. It may have the solid line which is connecting the two of that kind. Any kind can happen actually. Instead of 18, let it be 17, for example. See that it is coming down. Or maybe let it be 19, for example. Maybe it is going up actually. Or it may be 0. We don't know. Okay. Or it may be about 35, for example. It may go up. Okay. Or even it may go 100, for example. See that it can happen. This is the thing actually. Means, for example, if you are observing some phenomena, for example, like a solar eclipse, where you are monitoring the some amount of the radiation, which is linked to that. Immediately when eclipse happens, the intensity will come down. Immediately intensity come down and goes up for a short duration. Or if you are observing some phenomena, assume that some cyclone comes. Immediately the amount of water which is falling on the earth will be quite high. Means rainfall will be quite high. You'll get a peak. In 1 hour. Instead of that, for example, if you're monitoring the radiation, immediately rainfall occurs. For amount of the rain should be quite high only for few hours. Then you can have this type of a peak actually. Whether you connect it by line or not, that is different issue. While connecting this, see that there are several things actually you can modify. Like that you can use this one or this one, okay, or maybe this one. See, there are more or less. There are, or maybe with the grid you can use, with the double line you can use, maybe single line with the grid you can use. Okay, here you can change the color, or you can change dashed line or dotted line. Okay, this is an how the things are changing actually. Okay, there are several. See that. Let us presume one actually, which is not an issue. Let us presume of this kind actually. Okay. Okay. This is how kind. Even you can change the colors of either fonts or, for example, here. See that they are changing actually. Okay, quick access layouts are also available. Either which type you have to use, series of that. For example, if you use like this, okay, access title is coming here. X-axis I forget it here. Some time, what you can call time interval. Maybe in seconds, for example, or minutes, for example. Okay, this is number of apples which are fallen. Total number of apples. Total number of apple 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 fallen. This is a number. Okay, whether you can use this or not, if you delete it, entire thing will go with that. Here one, for one corresponding to that is 30. Okay, one corresponding to that is 30, two corresponds to that. It is giving the axis. See, instead of 100 here, I will give you an 18, for example, where you can notice data also it is printing 1 comma 30 is the first point, 2 comma 28 is the second point, 3 comma 36 is the third point of that kind actually. That kind of, this is one kind of a graph how one can do that. But instead of this, you can also add the second plot for this one. If you add second plot, for example, I will show you. Click on this. Okay. Select the data for the plotting. Okay. Here you can add. Okay. Series number. You can give sample 1 to here. Okay. Then set the value. Okay. This is the one. Maybe another plot is sample 1 here. Go here. Plot. 1 second. Plot this scatter. Okay. You can keep that at the bottom. Okay, this is how it is showing. This is how it is showing actually. In the sense, the data is changing. Data is changing every moment. Here, see that. This is the only thing. Whether y values are depending on x. Right now, 1 is there, 14 for 14. 2 maybe something else. Whether it depends or not, we don't know. If that is the case, for example, if I click here, or maybe some other kind. Okay. Some random number. This is some random number. Random number. Random behavior of numbers. Numbers changes randomly. Okay. If I click here, see that these numbers are changed. In the sense, the number is not uniform. You are also getting the plot. 1 need not be always 8, 2 need not be always 21, or 2 may be 49, or 3 may be 8. Any number can be changed. There is no perfect behavior. In a sense, these are the random numbers, or the variability is such a way that these y values are not depending on the x. If y value does not depend on x, there is no need to plot them on there is no need to plot them on scatter plot or a plot which is connecting between the lines. You can choose in such a way, here, you can go for the bar graph. You can go for the bar graph and everybody to charge quick layout. Okay. This is not required. Okay. As the bar graph shows, what it indicates, this is again, even though numbers are varying, for example, if I press, see that it's interactive. It is interactive. See, see, see. For example, like if you are allowing that share market, real-time data of the share market, how it changes from time to time. How it changes from time to time actually. Instead of time to time, maybe assume that fixed time. These are different markets. One is from Bangalore, one other from Bombay, another from Delhi, or maybe one from Reliance, one from some other share market, how that share market varies. Okay, or price of something, selling and purchasing will vary from one vendor to another vendor of that kind. Maybe they even nowadays, because of the changes in the market, the petroleum price is also changing from cities to cities. May not be of this order, at least. Okay, for example, if you click on this, see, for these type of things, means to say, whatever the case, one should be there. Maybe one entry, second entry, third entry, maybe Bangalore, Bombay, Delhi, Calcutta, or America, Japan, maybe Korea, or how that can. This is a random behavior. For these type of the things, we have to use the bar diagrams. Means there is no connectivity between y-axis and x-axis. But thing is that they represent how that trend can go, whether an increasing or maybe a decreasing, or whether relatively we can compare them, which is the maximum value among the given set, which is the minimum value among the given set. Instead of that, if you plot here, this is a fixed value. Since here I have chosen random values in such a way, random values also changes from time to time whenever I press. Whenever I press, this is one kind of effect. Means what it says that here we have to use scatter plot. Then another thing is the linear plot. We can connect between them. If we don't know what should be the value in between, we are not supposed to connect. Bar charts are the one, where you can connect them here of this kind. Okay, you can change the color, or that is different issue. Whether we have to choose x vertical bars or maybe horizontal bars, for example. If I do like this, okay, if I go here, of course, this is the different fonts and the grids. Maybe you can see one case actually where you also have the numbers here. Okay, numbers along with the text. Now, if I change, see, numbers are also automatically fetching. This is also automatically fetching. This is a good sign. If it is interactive, on real time it works. It does not require internet. It does not require. Means a program is written in an Excel in such a way that numbers are randomly changing whenever you press a key. whenever you press a key actually of random between that. Instead of random between this, assume that you can choose any other set. That will also happen actually. That will also happen. Even you can interchange this with y-axis. For example, here, let it be here. What it says, x-axis is x-axis grid is not there, but here you can have the variabilities. Still you can click. For example, see, means there is no hard and fast rule whether you can connect between x or maybe y. Both one is fixed, another one is variable. But for a corresponding x here, x doesn't make any sense. Which is the magnitude we want to know that at least. Means number one is having a 53. Number two always to be there as a two, but it will vary its variations. Number third will be fine. For example, okay. For example, score of a person, score of a student, you only in different papers. For example, almost start first semester one paper to a last semester. If I take some 16 to 20 paper, how the score can happen? It will vary between 1 to 100. There is no doubt. If there is a less than 40, we should not accept it. It should be a failure candidate. Then you can put a grid. Then you can put a barrier of that kind actually. Okay, listen. Okay, these plots you can choose. Here there are say that need not be recommended plots they can call. Okay, instead of that you can go for all. One is the template you can go, or column graph, this either horizontal or vertical. Even you can go with this type of random behavior also one can plot earlier graph actually. Random behavior. See, this is the 1, 2, 3, 4 random behavior, 90 of that kind. Where is the data? You can click on that data or here. See? See? Okay. Yeah, that kind. Means or you can plot. Means this is different versions. Thing is that you have to plot this data in your regular graph sheet. Then you have to transfer that to the computer for any modifier. See that these are several ways which are available with grid, without grid of that kind. It is only a demonstration how one can do that type of things actually. If it comes with the real values, we can do a lot. We can do a lot actually. See here. Maybe even three-dimensional graphs also you can plot. One after the other, stacking actually. Okay. See again, 1 to 15 is a continuous value. The number, see that series 1 to series 15, how it has to happen. Maybe on 2 dimension you can write. Okay, sorry. On a 2 dimension you can write. Okay, here. But for every plot, this is on 3 dimension. For every plot, it's having its own criteria. But we are not supposed to choose randomly unless we study their properties properly. Okay, this is another way of writing. Of course, you can't see that. This is not an ideal data for this. Here, this is a scatter. Fine, not this one. This one it has to go, or maybe like this, or maybe area graph. Okay, this is also an histogram they can write. I will show you histogram later actually. Okay, this is one after other plot along the data, how that trend goes. This trend values, it is not a good idea to draw for random numbers. I will do it for some other value. In the sense, I will delete entire graph. Okay, here you choose this value. Okay. See that how that area can go. Area under the curve gives you some values actually. You can estimate the area. You can also estimate the formula, and then you can call what, and then you can arrange for the physical significance. What you want out of it actually. For example, here, add labels, add trend line also it is there. You see that this is how the trend line. One formula it can give. You can expect that trend line how it has to go with this data. Maybe if it is an exponential. See, if you are expecting it as an exponential, it is not. If it is a linear, how that trend line it has to go. Even the ups and downs are there. If it is a logarithmic, how it has to happen. If it is a polynomial, then you can change the polynomial of order 1, 2, 3, 4. See, observe these lines actually. Okay, means if you want to do that, manually we had to do on our graph sheets. We have to do calculations. If we know what best fit we want actually, accordingly we can plot. Thing is that make use of the computer for helping you in all respect. Sample data we will work out, assume that. Okay, maybe we can extend it to the entire classroom. We may extend it to the entire rest of the part of that kind actually. Otherwise, it's too difficult. See. Okay, then maybe a power, for example, power of. Maybe moving averages I can call. How that moving averages can do that? Maybe 2-point average, 3-point average. If you are going for maximum averages, that becomes a linear of that kind. That becomes a linear line of that kind actually. Okay. This data. Okay. This data, I will plot it in another data of that kind actually. Here, what I will do, this data set is very less. I will choose one data set from internet, if you permit me. Okay. For example, you know that carbon dioxide CO2 variation over time from monoxide. One second, time scales block. This only fetching the data. I'm saying that this is one website. How that data can vary. For example, see that it is unfortunate. Okay. Since I'm from atmospheric background, I am seeing this data very beautiful. This is the February maximum 2022. This is the February 2021. It was the maximum value. See that 2017 for last 23. Here, how it has to vary. This is actual variation. This is a fit line. This is from 60 to till now. They are saying that. Okay. I will do one thing. If you go for last month data, see that how that last month data varies. These yellow dots are the average values. Average values. Okay. Last 1 year, if you fetch, see how that fetching there. This is the scenario. If you want full record, this is the case. Okay. If you want the grow data, see that how the data can grow. Okay. If not, the data if you want, sorry, interactive plots, for example, here. Yeah, fine. This is fine. If it is an interactive plot, do you want any query? If you want an interactive plots, how it has to go, you see that. This is how the variation can go. See that this is a maximum value. Blue line is best fit line, okay, increasing with some trend. Okay, trend line I can call. It is increasing always. Red line is the seasonal variations, only for carbon dioxide, trend with carbon dioxide. You can change here instead of 1960. If you bring here, see that, see 19 from last 10 years, from last 10 years, maybe from last few years. Within month also you can change. Okay, this is January from last few years of that kind. See that? Okay, from last year. This is one cycle. One cycle, how it has to vary the values of that kind. What I want to say is that this is how the things are changing. I will take this one data set. Okay, I will try to choose the same thing for plotting, for example. If you want a data for the same case, okay, data in CSV, Mauna Lava, monthly mean data, monthly mean data is fine. Fine. If I click, my God, see that this is how the data is given. If I want to plot the data I gave there later, okay, God, actually, my God, 1975, 78, 73, how many years are there? See that this is almost, okay, let it come, let it come, let it come. Fine. Okay, we'll do one thing. Here, what is there on the top? One is the year, another one is, another one is, one is year, another one is the values, and then date and average, monthly averages. I will take this data to the Excel sheet. Okay. Here, you have to convert format as the table. Same case. Data is in different format. It will be there. Okay. Here I will ask now to import open data from a recent desktop. Test one. Okay. Here there's conditional data text to format. Okay, it's text to columns. Text to columns. Okay, you can change this. This is fine. This is fine. This is fine. Finish. Okay, it reduces. It reduces. One is year. Second one is the same thing, and another one is the average year of that kind. Then okay. Then assume that this is the data value. Two plots. I will plot these two in a different Excel sheet. This is huge data. Huge in the sense it covers almost how many columns are there, how many rows are there? 768 rows are there. 768 rows are there. Okay, let us plot this. Okay, home, insert, okay, line graph if you wish. You select these two. Yeah, how you are here. Let us increase the size. Increase size. See that. From here to here, there is no value. 1950 to 2030, the same case. How that it is. See that here. What is the minimum and maximum value? If you know, that's far well and good. At the bottom, it is showing 312, and the maximum it is showing 419. Do one thing. While y-axis is there, up to 300, there is no variations. Let us put 300. Maximum, let it be. If that is the case, choose the grade. Okay, minimum is instead of 312 it is there, 312 we can put. My god, it is showing. Okay, it is showing. Here also it has started from 1960, 1990 average. Minimum year is minimum is 1958. 1958. Maximum is 2020. Maximum is 2022. 1958. If you click on this, okay, here 1958. Okay, let it be 58 fraction, and 2025 we can take. Okay, it is showing the variations. Means to say that this type of plotting we can do. We can fetch. If you want to do manually, it takes long time, but we have to practice for some sample data, then make use of the computer or maybe the any of the programs like either Excel or spreadsheets or any kind of these things for the plotting. You can name them it is an year, what I shown earlier. It is a trend, we can show that. How that line. Let us see that how that a trend line can go. Here, if I want to put some trend line, some data analysis I want to make actually, how that trend line, best trend line I can go actually. Here series options, chart horizontal plot area. For example, if you want to plot the area, it also estimates the area. Plot area. Okay. Plot series primary series. It is not come. Is okay. One best fit line I want to show data. Then okay. Then it will be. So if you click here, it will show you that axis X-axis, Y-axis, chart title, error bars. You can put the error bars also. How that error bars are calculated, you see that. I'll show you in maximized picture. See that horizontal and vertical error bars with some 5% standard deviation it will put. Okay. If here it is not required. Grid lines, let it be. Grid lines. Legend should be there. Okay, otherwise. Trend line you can put here. Yeah. What is the trend line? Here. It is there actually. I miss it. I miss it. Trend line you can go for linear or exponential. See that. If exponential means is different, or maybe exponential is like this. Okay. Yeah. Linear forecast it is there. Or two period moving average point. Two period of moving average point means every 2 points will be average and put together. Still you can have the more options. Under more options, you can click more action. In a sense, intention is that we should know that whether it should be linear plot or not. If not, we can choose that. Whatever you wish, we can do that. Whatever you wish means behind that there is a theory, there is a systematic way of representation. Such type of systematic way of representation one has to practice actually. One has to practice. This is up to the second one, bar charts. Pie charts, for example, pie charts. Okay, pie charts. What will happen? Let us choose the same data sets. Okay, here, this is the best data sets actually. This sample I will take. Insert. What is the pie chart? Where it will go? Pie chart, not this one. 3D pie charts. Yeah, here. 2D with extension. It's doing something else. 3D pie gum. Maybe donut shape. I will do example of this one. 3 pi, no issue. Okay. What it represent is that, remember here in the plot, okay, this is the values also you should remember. Values, if you want to remember, no. Yeah, first one is somewhere below is about how much is the value. 58 we have written. 58 we have written. What it is making, how do you know that which is 58, which is the one of that kind actually. Okay, if I click on this, format the data label, series name, show, no, character name, no. Value in terms of percentage is there. Either you show values or you can show percentage. For example, if it is a if it is a value, for example, where the 58 is there, that is appearing. See, for example, here 58 is for this one. Second number is for 3. Third number is for 7. Second number is 3 here. Third number is 17. Fourth number is second. Or it will make everything into 100%. 100%. How it makes an 100% actually? It will take all of them put together. Total. Uh, Not total actually. How it makes actually? This is the maximum and minimum value you can choose. What is the no. Pie chart is in such a way it makes them in total. This is the if it is in terms of if it is in terms of can I put yeah if it is chart table legend I missed that option here. Yes, here instead of this line options, yeah, instead of percentage, if you put values, for example, values instead of put percentage. Okay, means this is about this is about somewhere 50%, 13%. Where are those numbers? Somewhere 1, 2, 3, 4, 5, 6, 7. Seventh number is somewhere here. Yeah, 97. 97 is 15%. It takes the sum of all, means just sum of all. Sum is maximum sum 644. 644. 644. 644 is the total number. I will write here. 44 is the right number. For 644, what must be the percentage value? 644 becomes 100%. Okay. Okay. How I will do? I will do somewhere here. plus this number divided by 644, okay, into 100. Into 100, if you make, this is a 9%. See, you got the 9% here. Okay. If you drag this number, sorry, 2 digit, let it be 1 digit for you. Okay. Okay, let it be 2 digit because otherwise you will forget. If you drag, see, 15% for this number. 82% for this number. Out of this, what is the percentage contribution by the first entry? 58. 58, you may not understand. What is the 58? What is the 3? What is 17? What is 6? If there are total 100%, okay, all of them put together, total they can call actually 58 is the first entry. In the sense, 9% contribution for the first, second one 3%, third one, sorry, 0.5%, third one 2.6%, fourth one about 0.9%, maybe somewhere it is a 15. If you go for the estimating here, minimum and maximum, if you estimate, minimum is about 0.5 and maximum is about 15.1. Total put together should be the total sum. Total sum should be the 100%. 100%. How? That pie charts can be done. I don't know you got it or not. We can't convert all graphs into pie charts. There is a specific way to convert. Okay, this is a specific way to convert. How many portions you can assume that there are four. Assume that there are 16 students. 16 students in your batch. If I give 100 apple, you can take whatever the number you want. Maybe one person may take one, another person may take two. Somebody who is very strong may take five. Somebody who is strong may be taking more than five actually. Okay. At a time, if you are taking that, then we will divide in such a way that what percentage you got. Means let us say that if there are 100, you can say that some of you got 3 means 3% you got. Another person may be going to take 4 means 4. There is no fractional value. But there's no fractional value of that kind. Some of maybe all 100, if your madam, Anupama madam is taking, then Anupama madam is 100%. There is no bar chart required. There is no distribution at all. There is no distribution. Sometimes it may go with equal distribution also. Equal distribution means, for example, here, it is a sample data. I will do one thing, 50, okay, 50, I will take, okay. I will put entire thing 50-50. What you got? Even out of 50-50 also, all of them are getting 7%. If you add, put them together, okay, the summation should be 50-50-50 of 15 times, it comes to be around 750, or even if I leave 1 point, okay. See that? Everyone is getting 7%. Even if I delete some force, for example, here, okay, 10% each, means that is 50 is shared among 10. 10% is they are getting. If you add one more 50, for example, see 9%. If you add one more, oh, number is changing, 8%. So one person is getting 9% actually. Okay, that be another 50. Like that. Why it is 8 and 9? Because that depends on the number here it is fetching actually. The same thing. This is the property of a pie diagram. Pie diagram actually. Okay. Either pie diagram, what I shown here, either pie charts, you can use that. Means it should be completed for 100% or entire value should be taken as one circle. You make the change. While making linear fit method, this I will show another example. Okay. Linear method is nothing but best fit line how one can draw. This is the serial number. Okay, I will go for another sheet. Oh, here also I use. I'll go for another number. Somewhere serial, or maybe the time. For example, every 10 minutes, 20 minutes, or maybe every 10 seconds. For example, you can say 10 to 20 seconds. That it is a time interval. Time interval. Even you can go beyond this limit. Let it be an observation for about some 4 hours. Fine. 6 into 4, 240. About 4 hours observations. What you want to have here, the data. Data I will do, some random data I will choose. Random chart here, random between 0, 1. Some variable. 0, 1. This is up to this extent. Let it go to the extent of 0 to 1. It is choosing only 1. 0 to 1000. Somewhere, some number. Okay. If I take the measurement of some value for every 10 seconds, how that number is changing. Okay, I will go for one linear feed data, or maybe insert somewhere scatter graph you put like this, or like this, or like this, or like this, like this, like this. Okay. Before that, I will choose one scatter plot. Okay. This is how it has to be there. If it is a data value, for example, height, it will. What I want to is that here it is there 50th value. You know that what is the 50th value? If I click on 50th value, let it be chart on the top. Okay, with a larger number. Okay. 50th corresponds to 371. 50th corresponds to somewhere 371. You know that. Even if you click on the point here it will show that 371, 50, 371. Maybe somewhere here 70, 625. No issue. Whether this can be shifted later? No. Is it repetitivity? Or 50th observation is 371, 60th observation is 165. We are not supposed to change. The value of y depends on x value. If it is 50, then only 375 may happen. If you repeat the experiment, it may happen or that is different issue. See that right now, this is the randomly has changed. The randomly has changed. It can't be. But if I fit the values, for example, no line, let it be solid line. Okay, but not border. Fit. Okay. Error bar, for example. See that how that error is calculated here. X error, Y error, it is common. The X error and Y error, it is showing some percentage, which is the deviation point. Without that, they can call it as an error bars. Okay. Trend line. Y error is error bars. Error bars. Standard error, percentage of error, standard deviation, more options. If it is a standard error, that is a value. If it is a percentage of error, about 2%, 3% corresponding to that. The values at the top are having higher percentage, values at lower. If it is standard deviation, you can fix what much with the standard deviation. If you can click more options and it gives you the more values of that kind. No, don't worry. Let us say that we don't want error bars right now for time being. Okay, we don't want error bars for time being. Trend line, here I can say that there are several. If it is a linear, like best fit line, how that best fit line can happen. This is how it has to go. If it is an exponential, see that second line. If it is a linear forecast, the same thing. There is no difference between linear forecast and linear line. They are one and the same thing. 2-period moving average. See that, but between the 2 points, it is taking the average. Still, what I want to say, for example, like this, if you are having your data points, I will go with another one. 1, 2, 3, 4, 5, 6 points. Okay, let it be here 2, then 3, 4, 5, 6, 7. Okay, just two points. Okay, I will plot this. Insert line graph. I hope all of you can see right now. Sorry. Okay, here intention is that you can increase the change size, color, that you can do that, not an issue. Here also try to fit the trend line. See that if you put the trend line as a linear, there is no way sure you are getting. Assume that the top point is instead of 7, let it be 10. What you are expecting? See that just I changed 1 point. Okay, if I change this 10 point, we don't know. Line is shifting up. It is the best fit line. It is going down. There is no need to connect always all the points with the best fit line. I'm saying that. Okay, best fit line moves in such a way. This is a trend. For example, instead of that, if I make 9, yeah, still it is not following all the points actually. Shall I go with instead of linear? I will choose it as an exponential. For example, trend line instead of linear, I will choose it as an exponential. What happens? See, oh, more number. Even one value is rising, up, moving away from its deviation. It is an exponential curve. It is exponential. Can we go for the logarithmic? Can we go for The more options of that kind. Can you go for the 2-point average? Can you go for the linear forecast? See, forecast goes like this actually. Straight line, you see that. This is a straight line. This is the linear line. This is the linear line. This is the exponential line. Okay, this is the linear forecast. Depending on the data, don't get confusion in such a way that data is not numbers. For mathematicians, they work with the data. For statisticians, they work with the data. For others, they work with the data. Maybe in the practical experience, actually, the data means numbers for them. For us also, apart from numbers, the major intention is that the information, how that information is changing, how that information is brought, what is hidden there, where whether y depends on x or not. If it does not depend on x, there is no need to plot. We can have anything as a trend. If it depends how it varies, whether increasing, decreasing, changing its values randomly, or maybe the trend, maybe the smooth line, like whatever you can expect actually. Why we are connecting between these 2 points? Because we don't know what is happening. Means, but we are making an assumption chart here that it varies. With increasing x, y will increase. With increasing in x, again y will increase. With increasing x, y will increase. In between, for example, something happening, the value of y may come down, value may go drastically up, value may remains constant. Value, we don't know what will happen actually. There are so many secrets in the universe. We don't know the reason for that. But whatever you are doing in your practicals, either in optics or general lab or electronics or any of the experiments in any of the specialized branches of physics like condensed matter or nuclear or maybe spectroscopy, bring that data and calculate in your computer lab how best you can do it. If you are having any doubt, I am happy to attempt. Otherwise, I'll stop here and I will explain rest of them in your lab. If there are any particular thing, we'll see that. We will repeat this for these 2 days. The same thing you can do it in your spreadsheet also. Any particular queries? If there are no particular queries, I will stop. I will end this class. Then I will come and join.